Okay, let's take a look at review for test 4, lessons 13 through 15. Our first question, the American Society reports the following information on its website. Overall, the chance that a man will develop lung cancer in his lifetime is about 1 in 13. Let's go ahead and highlight that. For a woman, the chance of risk is about 1 in 16. These numbers include both smokers and non-smokers. For smokers, the risk is much higher. For non-smokers, the risk is lower. According to the data given about women, what percent of women will develop lung cancer in their lifetime? So remember, for any of these equations where we're talking, or any of these problems where we're talking about chance of, percent of, when we have 1 out of 16, which is women, we're simply going to set up our ratio 1 out of 16 and then just divide. And we get 0.0625 or 6.25%. And then we can also use this to answer our next question. If 1 in 16 women develop lung cancer, how many women in every 100 will develop lung cancer in their lifetime? Since we've already determined our 6.25%, well, let's go this way. Let's take our 0.0625 per woman, multiply that by 100 women, and we get, we're decimal over, 6.25 women per 100. And if we wanted to round down, we could just say 6 women. Going on to number 2. What percent of men, non-smokers at age 60, will die of a heart attack in the next 10 years? So we have men who are 60 and who never smoked. So we're looking right here at 32, but note it's out of 1,000. So this is 32 out of 1,000. .032 or 3.2%. So anytime we need to make a look, make sure that we know the number that we're out of. A lot of times it's going to be 100, like number 1. Sometimes it's going to be 1,000. Sometimes it's going to be more than 1,000. But whatever that number is, that's the denominator, the population. All right, let's take a look at number 3. About 16% of drivers are uninsured. Approximately 196 million drivers in the United States. How many of those are likely uninsured? All right. So here we're going to convert our percentage back to a decimal. So we have 196 million. Now we don't have to put the zeros here. We can just do 196 and remember that it's a million. Times, and 16% in decimal form is 0.16. 196 times 0.16. And we get 31,360,000. See. And that says, if 16% of drivers are uninsured, how many drivers out of a million? So we would need 16% of a million, which would be D, without even doing any math. Because 10% of a million is 100,000. So that tells us that 16% is going to be larger than 100,000, and 160K is the only one larger than 100,000. All right, number 4. Which graph matches the statement that ventilator-assisted pneumonia accounts for 60% of all deaths from hospital-acquired infections? So if we look at A has death and survival, so we're not worried about that one. B has death from hospital-acquired infections. So there's our population that we were talking about. And then we have ventilator-associated pneumonia and other infections. Now, if we look over, well, we also eliminate D. If we look over, C looks remarkably similar. Deaths from hospital-acquired infections, ventilator-associated pneumonia, other infections. So you could be torn between these two. However, 60% is greater than a half. So our ventilator-associated pneumonia here in mustard needs to be greater than a half. So it's B. Number 5. University of Washington is a large public university, while Puget Sound is a small private university. Both are expecting 12% more freshmen next year. Which university will see the greatest absolute change? So remember, absolute change is change in the actual numbers, not a percent change, but 50 more students versus 25% more students. So since Puget Sound is smaller, they will have fewer freshmen to begin with. So 12% increase will translate to larger absolute change. That's incorrect. Since University of Washington is larger and they have more freshmen to begin with, thus a 12% change will not translate. No, that one's incorrect. Both will no. Since University of Washington is larger and more freshmen to begin with, a 12% translation will increase larger. Here we go. And we can see this if we say University of Washington, so UW, has 100 freshmen and they get a 12% increase, they're going to go up 12. If Puget Sound has 50 freshmen, they're only going to go up 6. So you can see same relative increase, larger absolute increase because University of Washington has a larger initial population. Number 6, which graph matches the statement that 28% of all ventilated patients develop ventilator-associated pneumonia? So our population is ventilated patients. So we can automatically eliminate C and A because B and D have the proper population, ventilated patients. 28%, so 28% is slightly more than a quarter. In this case, our VAP is our mustard color. So we can see B, our mustard, our pneumonia is about a quarter, where D, it's almost 3/4. So not D, we're going to grab B. So remember, the total population should be the title of our pie chart. All right, 12 through 17. Test 500 athletes, performance enhancing drugs, bad athletes. A positive result indicates the athlete is using performance enhancing drugs, and negative indicates they're not. However, the tests are not 100% accurate, so errors occur. The table shows test results for a group of athletes. So let's fill out our table. So we've got 90 using PEDs, and it's out of a total of 94 positive test results. So we have 4 false positives, meaning they're clean, but they tested positive. We have 90 using PEDs and 100 total, so we had 10 false negatives, meaning they were using, but they came up negative. So we have 396 proper negatives. That's 400, and we have 400 not using. So 1 in 5 are being bad students. According to the data in the table, how many athletes are using performance-enhancing drugs? So performance-enhancing drugs, we're looking at our first column. So this is 100 students. How many athletes received a negative test result? So negative test result, we're looking at this row, and that is 406. What percent of athletes received a positive test result? So if we look at the total for positive test results out of the total population, we have 94 out of 500. Or 0.188 or 18.8%. How many students not using PEDS? So this would be, change color. This would be our clean students here, received a positive test result. That would be these poor saps here whose world's going to suck even though they didn't do anything wrong. So we come back here. How many athletes not using PEDS? So we have 4. And then finally, next, number 11, test is negative. So we're going to look at the negative test result row. What is the probability they're actually using performance enhancing? So we have 10 out of 406. So 10 divided by 406. We have 0.025 or 2.5%. If the test is positive, what's the probability that they receive a false positive? So here, test is positive. We're looking at our test is positive row. We have these 4 false positives here, and we have a total of 94. So we have 4 out of 94. It should be about 5%-ish. 4.25. So 0.425 or 4.25%.